take a lamp emitting some light. Now this light comes in photons, which are basically just small packets of energy. These photons hit a piece of metal, which causes some electrons to shoot out of it. This is known as the photoelectric effect. But how does it work? As photons enter the metal, electrons inside absorb them, causing them to gain energy. Gaining enough energy means they can escape. Imagine the electrons are astronauts boarding a rocket ship to go to planet Mars. Of course, they'll need a lot of fuel to make the journey. Fueling our ship with less powerful fuel would mean that after launch, we wouldn't get too far. But if we were to fuel our ship with better fuel, we would be able to leave the Earth successfully. Now, our ship is free to go to Mars or anywhere it pleases with the extra energy that it had. In our case, the fuel is actually the photons, and the Earth's gravitational potential energy represents the potential energy of the metal. Using better fuel actually means that electrons absorb the photons of a higher level of energy. This happens when the photons are of a higher frequency. Electrons can only absorb the energy of one photon at a time, and therefore, if the photons are not of a high enough frequency, it does not matter how intense the light is. This effect is actually incredibly useful, used in things like night vision goggles, the Geiger counter, solar panels, and it is the motivation behind the invention of the first model of the atom that explained atomic spectra, which is basically the fingerprint of atoms. The explanation of the photoelectric effect by Einstein changed the course of modern physics, changing how physicists thought of energy from something that is continuous, like a river, to something that is coarse, like sand. It showed us that light is not simply a wave, but behaves also as a particle. This opened the doors to the dual nature of light and many strange phenomena predicted by a new theory of the universe: quantum mechanics.